Which numbers do we want to see you go over? Have questions about? Show me your hands. Everyone is voting. I did see multiple threes. If you had a 3, you can put your hand down. If you had anything else, keep your hand out. So we'll do 3 and 2, and then the last one between 4 and 5. Everyone votes. Put up a 4 or a 5. I think 4, 1. So 2, 3, and 4. And then any of those that can be done in decimals, we will also do. For Shortcut 18, I'll let you guys choose whether you want to see it algebraically or in decimals for each one of you. Right. For number 2, you have to evaluate, put both of these into x and y. Because we have a negative, you should be using parentheses. If you don't use the parentheses, you're going to end up with negative when it should be positive. So this would be positive 1 minus 9. You can put parentheses here too, is what I meant to do. Which would give us negative 6. Questions on that one? Number 3, if you distributed, we have 7x minus 6 equals x plus 6x plus 30. And then combine your like terms. So here we see that we have the same coefficient but different constants, so that would be no solution. But if you kept solving, let's say you got rid of the variable terms, you don't need to do this. You would see that you got 2 different numbers that are not the same, so that again would be no solution. Question on 3. And then number 4. This one you would have to do on the graph. The x-intercept of this graph there is 1. And it's at the point negative 1, 0. So the first 2 I'll show you in Desmos. You could do number 2 one of 2 ways. 1, put it in exactly as we did, 3 times negative 1 squared, 1, minus 3 squared. And it would show you that same answer. Or you can type in the x and y, make them capital. It won't work if they're lowercase because Desmos uses it to graph. But if you capitalize them, it will have you as sliders. If you add in the sliders, you can change the values of those 2 numbers to negative 1 and 3. And then it'll take those 2 numbers, 2 values, and put it into your expression and simplify it for you. Questions on that one? Number 3, if you typed all of that into Desmos, nothing would show up. But if you typed in both sides separately, you'll see that if you counted, these two lines have the same slope and they're never going to cross because they're parallel lines, so you would have no solution. Questions on that? Alright, so we're going to start our next lesson with systems, and this is the second part of how to do it algebraically by elimination. Go ahead and fill this out. The top is a little small, but it says add or subtract or multiply and then add or subtract to eliminate a variable. Make sure the equations are lined up. Add or subtract equations to eliminate the variable with common coefficients. Solve the equation for the remaining variable. Substitute your answer into either equation and solve for the variable. So kind of like substitution, the last part, but the first part is different. And then if there aren't common coefficients, multiply one or both equations by a number to make them common. So we'll show different examples where all of these different things may apply. Once you're finished writing, if you want to tear that first page off so you can use the back of it, because some of the boxes on the notes are a little small to do your work. But if you think that's enough space, then that's fine. Or you can just leave it open. Let's start with example number 1. Make sure the equations are lined up. Right now they are. The y's are on top of each other, the x's are on top of each other, the constants are on top of each other. And then add or subtract the equation to eliminate the variable with common coefficients. So first, what does it mean to eliminate? Take out, get rid of. So which of these two variables have the same or similar coefficient? Y. So we could get rid of y by adding or subtracting? Subtracting. So we're going to subtract both equations together. We're going to do this vertically. So y minus y would give us 0. So it is now eliminated. 3x minus x would give us 2x. 4 minus a negative 2. Be careful here because that would be a plus. And then, now that we've eliminated one variable, we can go back and solve for x. How would we do that? And then divide both sides by 2. So that's part of it. Just like with substitution, we have to solve for both the x and y. So you can take this and put it into either equation. It does not matter. This is where it's the same as substitution. Put it into one of the equations and find y. I'm going to put it into the second one. And then we could write that as an ordered pair. The solution would be what? -3. -3, -5. Questions so far? Go ahead.
How -2 plus 4 is
Here?
Mhm.
Because here it's 4 plus 2. Because it would be 4 minus a negative, and that would become a plus.
Mm.
Any other questions? Okay, did you have a question?
Yeah.
For number 2, these are all lined up. Even though they're in a different format, they're still lined up. They don't need to be in this format, the y equals mx plus b. They can be in either or. So if we were to add or subtract to eliminate a variable that has a common coefficient, which one, x or y, has a common coefficient? X. So to eliminate x, we would add or subtract. Subtract. So subtract both equations together. X minus x would give us 0. 4y, be careful with the negatives. Minus y, minus a negative y would be a plus. And then 13 minus 3 would be 9. We've eliminated x, so we could solve for y. Divide both sides by 5. How do you get 13 minus 3. Then you can take that and put it into either equation. It doesn't matter which one. I'm going to put it into the second one just because. And solve for x. And we would write that as an ordered pair, 5. All of your check methods still work on elimination as well as it did substitution. So if you want to take that ordered pair, put it into both equations to double check to see, did you do this right? You could do that. If you want to solve both equations, get them in slope-intercept form, to put them in your calculator, you could do that. If you want to put them in Desmos while you're practicing to check and see is that the correct solution, you could also do that. So we've done a y and x. Yes.
Can we try 5?
We can try 5. I was also looking at the a negative equation. So let's do 4 first. They are lined up. Which one is the common or similar coefficient? Negative 4. 4 and 4. So for x, it can be negative and positive. One can be negative, one can be positive, or they can both be the same. It doesn't matter. If we were to eliminate these x's, would we add or subtract? Subtract. Okay, so I'm going to show you this, and if you're not sure, ever do this. So if I were to subtract them together, 4 minus a negative 4 didn't eliminate. But if I added them together, basically I'm just subtracting in general, but that would. But think about what you're doing to the entire, like both equations, not what you would be doing in general. If they are the same, so if they're both negative or if they're both positive, you're going to be subtracting. If one is positive, one is negative, you're going to add in general. So if we add both of these together, 4 plus a negative would give us 0. 9 plus 7 would give us 16. Y. 5 plus 11 would also give us 16. Divide both sides so that y is 1. And then take this one, put it back into either equation. It does not matter which one. Let's do the first one. We have 4x plus 9 equals 5. Get rid of 9. So that x equals -1. So we have the point -1, 1. Questions so far about how elimination works? We'll do number 5 and then we'll see how many times something for lunch. now, number 5, they are not lined up. Yes, the x's, the y's, and the constants are on top of each other, but the equals is not lined up. So we either have to make the first look like the second or the second look like the first. Which one do we want to change, the first or the second?
The second.
Okay. So if we change the second to look like the first, we have to move the 3y to the other side by adding it. If you want to rewrite both, you can do that. Oh, okay. And then which of those would we be eliminating? The y. By adding or subtracting? Subtracting. To subtract both equations, be careful with your negatives. Negative x minus 2x. This would become 0y. 11 minus 10 is 1. And then we could just solve for x. Ignore the 0. Divide both sides by negative 3. This one is going to have fractions. Sometimes that happens. So then you can put that back into, I'm going to put it back into this first one, but you have choices, the first or the second, the originals, or the one that you change. Any of those would work. I'm going to do this up here. We have positive 1/3 equals 3y plus 11. And then you can either do this next part in the calculator or by hand. Subtract 11. And then you can divide by 3, or you can take the 3 and flip it and multiply by 1/3. I'm going to do that so I don't have a fraction within a fraction. So this one was not a nice one because we get some ugly, not a nice fraction. Negative 1/3. And negative 32 minutes would be our solution. Before we go on to some other ones, did we have questions on number 5? Now we're going to jump into some like number 9. So on 9, excuse me, they are lined up. Do we have common coefficients? No. So this would be a case where we have to make common coefficients before we can add or subtract. You can choose to eliminate the x's or the y's. It doesn't matter. Let's say we're choosing to eliminate the x's because 1 is a 1 and 1 is a 2. You have to multiply one or both of them by something that would make them the same. So this one is already 2. What could I multiply this to make this 2? Yeah. But you're going to do that to the entire equation, not just a piece of it. I'll write this down so you get your copies. So we're going to multiply 2 to everything, rewrite that. So it becomes a whole new equation. Then everything else is the same. So to eliminate our x's, would we add or subtract? Subtract. So we're going to subtract everything. negative 7y minus 6y would be negative 13y. Negative 1 minus 12 would be negative 13. This would be 0. You can put the 0, you don't need to put the 0, those are due. Divide both sides by negative 15. Then take that y, and now you have three options of where to put this in either of the original two equations or the one that you changed. It does not matter, you should get the same answer no matter what. I'm going to put it in the first one. Again, you could choose to use a different one if you want. So for this, if I subtract, x is what? So that order pair would be 3. Questions on that problem? Now let's look at 10. Similar to 9, but we don't have just a variable by itself, so we can't just multiply by whatever it is. So again, you have a choice. You can eliminate x or y, so which one do you want to eliminate? I heard x first, but if you want to eliminate y, it's the same process. You have to think of something these could both change into, so something they both multiply to be. What would something they both multiply to be? 15. So I can multiply this by 5, the first one, and the second one by 3. And you're going to multiply both, change them completely. And then the rest is the same. So to eliminate our x's, we would add or subtract. We have 0x, or just 0, plus 3y equals 15. And then solve for y. Then when you go to put y back in, you now have 4 options. You can put it in either of the 2 originals or either of the 2 new equations that you just solved for. It doesn't matter, whichever one you want. Let's say I chose the first one. Did we get -2? So then that order pair would be -2. I was trying to think of the special case ones. I want to say 14 is 7.
How do I do 7?
Okay, so we can go back to 7. I think 7 is also a special case.
Is 8 no solution?
I don't know off the top of my head, but it could be a special case. For 7, if I were to eliminate one of the variables, it doesn't matter which one, really, they're both going to eliminate. But which one do we want to eliminate? Sure. So we would do that by adding or subtracting. Subtract. Okay. So when we do that, 3 minus 3, we know that's 0. -4 minus -4 would be the same thing as -4 plus 4, so that's also 0. And -10 minus 13 would be plus 13. So this would be what type of solution? Yes.
I'm more concerned about the fact that the first question doesn't have an equal sign.
Oh.
That's why I was confused. That's no solution.
So yes, this would be no. So when you get your special cases, as you're eliminating, if they're the same already, you'll realize real quick if it's no solution or if only many. But if they're not the same, like I want to say 14, you would have to change them first, multiply one or both, then solve, then figure that out. So let's do 14. We'll look at any others you guys want to see, and then you'll have time to practice. So right now they are not the same. We want to make the x's or the y's the same. The y's, okay. So think of a number that these both go into. 12. So I would have to multiply the first one by 3 and the second one by 2. So let's do that. You can kind of see already that this is going to be a special case because my x's are the same, my y's are the same, my constants are different. So if I were to eliminate this, subtracting, I get 0 and -6, which would be what type of solution?
No solution.
Are there any others that we want to see, do, go over, have questions about? We do 8. Okay. Do we want to eliminate x or y?
X.
Okay. If we're eliminating x, would we add or subtract those together?
Add.
As we're adding these, this becomes 0, but this also becomes 0, both x and y. -10 plus 10 is also 0. So this would be what type of solution? Any others? 12, they are not the same. Do we want to eliminate x's or y's? Any questions? Okay, and then we do x.
If it's considered, it's like another.
Yes. Most of the time with elimination, you're going to get 0 equals 0. So with substitution, you could get two different, a different number equals that same number. But elimination, you usually get 0 equals 0. Solving for x. What number do these both go into? 14. So we can multiply the bottom by 2. Even though this is negative, we can still just multiply it by 7. Or if you want to get rid of the negative, you can multiply it by a -7. That choice is up to you. When you start to do the delta math, you may see that they make you multiply by a negative. You don't have to do that. Alright, so 14x plus 10y equals -26. -14x minus 49y equals, what is 7?
182. 182.
1 flat.
182.
Okay, and then to eliminate our x's, would we add or subtract?
Add.
Add. So let's add those together, see what we get. 14s would cancel. 10 plus -49 would be like 10 minus 49, -39y. -26 plus 182 is what? Okay. And then if we divide, what is y? I know, how do we -4. Right. Then we can put that back into any of the equations, doesn't matter which one. do the first one. 7x plus 5 times negative 4 equals negative 30. I'm working so perfect. Sorry. So, what was x?
X is 1.
1. So 1, negative 4 should have been your solution. Six. I think that's a good amount. Do we have any questions in general about how to solve systems by elimination? So then today you could be working on a few things. The rest of these problems, your Delta Math on this set is due next Friday. The 2 Delta Maths that are due today, if you haven't already, on substitution and graphing. You can go back to your graphing or substitution notes and work on any of those. I will look and see if I have more elimination practice, if you would like more practice after that. I do need to talk to a couple of you for course recommendations, but you guys can work together, use your notes, use Desnotes to check yourself or your calculator. Let me know if anything can help.